Hey, what is going on everyone? I'm Wicked, welcome back to my Dart from Novice to Expert complete course. I hope you're doing really well. In this tutorial, we're going to hop on the Flutterly train and move over to the next important station of our Dart language tour, and that is Dart operators. So without further ado, let's get right into it. Beforehand though, I want to send a token of appreciation to everyone supporting me as official YouTube members, especially to Diana and Michael aka Aza on Discord. If you want to become a member, all you have to do is to click the join button right next to my channel and pick your desired membership. Having that said, let's continue with our tutorial. Now, having in mind that in the previous tutorials we learned everything about Dart variables, types and functions, now it's finally time to glance over Dart operators. What you actually need to understand at first is that the majority of the operators that we're going to discuss today are no more than functions. It may seem a little bit strange at first, but take a look at the num class for example. You can clearly see that plus, minus, division and multiply operators are basically special functions having their names set to the specific operator sign. The plus operator, for example, takes two operands, the one calling it and the one that wants to be added to the caller, denoted by the other parameter here. One thing to be extracted from here is that for operators that take two operands, the leftmost operand determines which method is used. For example, if we have an integer a variable and a double b variable, if we call the plus operator by writing a plus b, then the plus function that is going to be called is the one from inside the integers class, since that's the leftmost operand. In our case though, both types extend num, so it doesn't really matter since the num class implements the plus operator, because calling a plus b or b plus a will eventually call the same method from inside the num class. However, if you have something like these two classes both having their own specific plus operator, you can see that if I call a plus b, the program uses the plus operator from class a, and if I call b plus a, it uses the one from the b class, highlighting what I said earlier. Think of these operators as being written like this: a period plus b and b period plus a. Since that's what is actually happening in the background, both objects are accessing their own plus method via the dot operator. So having this in mind, let's glance over all the operators that we're going to discuss today. These are actually all the operators Dart supports, and if you pause the video, you'll notice that most of them have been already used and covered in previous tutorials. Each of these operators can be split between multiple categories, so that will facilitate the learning process. We can see arithmetic operators, relational operators, equality operators, and so on and so forth. Nevertheless, in order to make this tutorial not boring at all, for each category of operators, I'll only discuss the important things you need to know, because well, I guess you already know how to use the plus operator to add two integers, right? Before we get started, there's still one more thing to be mentioned about the order in which the operators are displayed here. Each operator has higher precedence than the operators in the rows that follow it. So, for example, if we will have this quite unreadable but correct line of code, we can deduce the order in which each operation is executed by looking at the table. We can see that first and foremost, Dart is going to use the unary postfix list access operator to retrieve the value from the list at the specific index, then it will calculate all multiplicative arithmetic operations, then additive ones, then it will take a look at the relations and equality operators, then it will calculate the expressions by using the logical operators, and then only at the end, when the entire expression is calculated, the resulting value is assigned to the variable. By surrounding specific expressions with parentheses, you can tell Dart to evaluate those first. Now, you heard me a lot of times talking about expressions, but what are expressions? Well, when we use operators, we actually create expressions. Adding two values by using the plus operator creates an expression. Comparing the equality of two variables by using the equals equals operator creates also an expression. Even assigning a variable to another variable creates an expression. Everywhere you'll see operators, you'll also see expressions. Finally, after having this said, let's get to the first type of operators you'll find inside Dart. arithmetic operators. I'm displaying each and every one of them on the screen right now, and from what I can deduce, you should be already familiar with each and every one of these, since we used them a lot in the previous tutorials. In this section, I want to discuss the division and modulus operators first. So when dividing two numbers that are not divisible, you have two choices. You either retrieve the double value resulting from the division by using this divide operator, or what you could do is retrieve the integer part plus the remainder part of this division by using the tilde slash operator and the percent operator denoting the modulo operation. In this case, 7 divided by 2 equals an integer of 3 and the remainder of 1, since 3 multiplied by 2 plus 1 equals 7. And another important fact to be discussed about arithmetic operators is that Dart supports both prefix and postfix increment and decrement operators. Take a look at the following example. If we have an integer value a equals 5 and we sequentially call a++, then print the value of a, then call ++a and print again the value of a, we shall see that a got incremented twice, once to 6 and once to 7. So, if we assign these values to two variables a1 and a2 and print them again, we shall see the same result, right? Well, as you can observe, it's not like that. It seems like it didn't increment for the first time, but it did for the second time. Pretty strange, right? What a++ actually does is that it first assigns the value to the a variable, then only after that it increments it, whereas ++a increments the a value at first and only then it assigns it to the variable. This is really important to be taken in mind, and this is what actually happened in our case. Dart assigned the a1 variable to the current value of a, which was 5. Then it incremented the value of a to 6, a step which we cannot see in the code unfortunately. Then, when we called ++a, Dart incremented the current value at first, which is 6, and took the result of 7 and assigned it to the variable. The same thing applies with the minus operator as well, and I think this is pretty much everything you need to know about these arithmetic operators. It's time to move on to the next category, equality and relational operators. Here's the list of all operators in this category. These are for the equality and these are relational. I'm sure all of you know what greater and less than means when comparing two integers, for example, so I'm not going to get deeply into that. What I want to discuss, however, is how Dart calculates the equality of two objects. By default, in Dart, two objects are equal if and only if they point to the same object in memory. So, if we have two integers both holding the same value of 2, they are equal because, as we have previously learned, 2 is a constant value object, therefore it doesn't matter how many times we'll instantiate it, it will always be the same constant instance. However, if we instantiate two lists holding the same values, we learn that these are not constant lists unless we prefix them with the const keyword. So, comparing list 1 with list 2 will end up in a false value. One function that checks whether two references are pointing to the same object is identical, and by default, in Dart, the equal operator is performing the same as this identical function. So then, why are two methods doing the same thing in Dart? Well, because compared to the identical method, which will always check whether two references are pointing to the same object, the equal operator can be overridden in specific cases. For example, if we have a class A holding two values of integer, if we create two instances of A with the same values inside and check whether they're equal, you'll see that both identical and equal operator return false, because indeed they're holding references to two completely different objects in memory. But in this case, we may want the equal operator to return true if two instances have the same integer values inside. By using the VS Code Dart data class generator plugin, we can override the equal operator really easy by hitting Ctrl+, and choosing generate equality. Without any hassle, the plugin automatically generated the overridden equal operator. When overriding this operator, we also need to override the hashcode getter, and you can see that the plugin takes care of that too, by XORing the hashcodes of all fields altogether. The generated code is even optimized, since there's no need to check whether the values inside are equal if Dart detects they point to the same object in memory by default. Now, if we check if these two objects are equal and identical again, we can see that thanks to the overridden equal operator, they are equal, since what Dart does now is compare the values from inside of it. But they're definitely not identical, because they're not pointing to the same object in memory. We can optimize this code even more by turning this class into a constant one with a constant constructor. Now, if we run the program again, we'll see that those objects are equal and identical at the same time. And a quick tip I can give you when you want to implement this equality in a more neat way is that you can use the equatable package as a dependency to your package. So get the equatable package, then all you need to do is to extend your class with it, import the package at the top, and then, as you can see, override the props list. The props list represent the fields from inside your class that you want to be compared inside the equal operator function. So we'll pass both variables, since we want two objects to be equal only if they have the same values set to A and B. If we run the program again, we actually receive the same result as before, but this time the code looks more structured and much easier to read and understand. Having this said, I hope you understood how Dart compares objects by default and how you can override the equal operator in order to compare your objects field by field. It's now time to move to the next category, the type test operators. This is a really important one, so make sure you pay as much attention as possible. There are 3 operators in this section, and all are equally as important. So let's cover each one of them right away. The as keyword is used most of the time to cast a type to another type. However, it has another functionality serving as the keyword preceding library prefixes. So when you want to have an alias for an imported library, you can write import math.dart as math and access the library by using that specific alias. Now let's talk a little bit about the typecast functionality. You might remember when I told you that you can have a list of multiple objects of any type, right? Well, what if you want to access the specific methods from inside each of these individual type objects? What does Dart currently know is that each of the objects inside the list are of a nullable type object. So we need to specifically cast each object we need to the right type. We can do that by using the as operator, just like you can see on the screen right now. But there's one potential issue with that, because you should use the as typecast only when you are 100% sure that the object you're casting to is indeed of a correct subtype. If the object can't be cast to that type, you'll end up with a typecast exception. So, if you're not 100% sure that an object is of that type you want to cast to, Dart comes with another 2 important operators, is and is not. The is operator returns true only if the object is of the specified type. For example, instead of typecasting each of the values to their type, we could iterate through the list by using for each, and for each element we can check if it's of type integer, double, string, and so on and so forth by using the is operator. Note that Dart is smart enough to automatically convert the element to the right type inside the scope of the if statement, so that you will be able to access the specific methods directly. And I think you can imagine by yourself that the is not operator does the complete opposite, meaning it evaluates to true only if the object doesn't have the specified type. It's finally time to move on to another category, the assignment operators. Now, I'm sure a lot of you already know what equal operator does, so I'm not going to bother you with that. However, I can bet a lot of you didn't know that you have a shorthand syntax for whenever you want to assign a value to a variable only if the variable hasn't been assigned yet, i.e., it's null. You can do that by prefixing the equal operator with 2 question marks, just like this. This is quite useful when you have an object that you don't want to instantiate multiple times. Now, we have previously seen in the arithmetic operators section that you can increment a value quickly by writing a++ or ++a. Those are great when you want to quickly increment by 1. But what if you want to increment by 3 and you don't want to use the long syntax like a equals a plus 3? If that's the case, you can use compound assignment operators, one of them being plus equal, to do it. So you can write a plus equal 3 and pay attention because this is equal to writing a equals a plus 3 or plus plus a plus plus a plus plus a and not a plus plus, a plus plus and a plus plus. Remember, the latter assigns the value before incrementing it. There are a bunch of compound assignment operators like minus equal, division equal, modulo equal, multiply equal, and you can even use the bitwise and shift operators with those, but we'll talk about them a little bit later on. Now, let's talk a little bit about logical operators. These are some operators you'll find yourself using most of the time, especially when you want to combine multiple Boolean expressions one after another. So yeah, one thing to be noted here is that they only work on expressions that evaluate into Boolean values. The exclamation mark before an expression inverts it, i.e. changes false to true and true to false. You can see that the logical OR and AND operators have double vertical slashes and double ampersands. Note that in Dart, there are also operators having only one vertical slash and one ampersand. Those are bit operators. So let's talk about them up next. Say for example we have an integer initialized with 6. This in binary code is written like 0, 1, 1, 0 because 2 to the power of 1 is 2 plus 2 to the power of 2 is 4. 2 plus 4 is 6, which is our value. And let's say we have another value b, which is equal to 5. This is equal to 0, 1, 0, 1 in binary code, having the same calculations in mind. So, if we apply the AND operator between them, then the result will be 0, 1, 0, 0, which is equal to 4. And if we apply the OR operator between them, then the result will be 0, 1, 1, 1, which is equal to the value of 7. If we apply the XOR operator between them, the result will be 0, 0, 1, 1, which is equal to the value of 3. We can also apply the left shift operator on A. Then the result will be 1, 1, 0, 0, which is equal to the value of 12. And if we apply the right shift operator on our A value, then the result will be 0, 0, 1, 1, which is 3. We can also find the unary bitwise complement of a number by prefixing it with a tilde. Bit operators can be really useful in some situations when you want to calculate values really fast. However, I find myself using the solutions to these situations from Stack Overflow. Now, it's time to move on to conditional expressions because these are one of the most important time-saving techniques you'll ever use inside Dart and Flutter during your development workflow. That is because instead of writing a function like this with an if-else statement, you can have something like this. So, everywhere you want to use an if-else simple statement like this, you can use this conditional expression. If this condition is true, then it will evaluate the first expression, and if it's false, it will evaluate the second expression after the colon operator. What's even cooler is that if you want to write something like this, you have a much cleaner way to write it, and that is this. In this case, if expression 1 evaluation is not null, it returns its evaluation. Otherwise, it evaluates and returns the value of expression 2. I mean, from this entire function we initially wrote, we arrived at this shorthand really cool alternative. There are a couple of more operators to cover, but I'm sure you already know them by now since I explained them bit by bit during the built-in types tutorial. So make sure to revisit it by clicking the card in the top right corner of the screen. Having that said, it is finally time to end this tutorial on Dart operators. I hope you understood them in great detail. In the next tutorial, we'll move over to the next station on this Dart language tour, in which we'll discuss all the control flow statements in Dart. As always, if you like this tutorial, don't forget to smash that like button, subscribe to my channel, and share the video with all of your friends and colleagues in pursuit of top tier development. Until next time, as always, take care, Wicked is out, bye bye.